Hello friends, today's question: two coaxial disks having moment of inertia I1 and I1 by 2 are rotating respectively with angular velocity omega 1 and omega 1 by 2 about their common axis. They are brought in contact with each other after some time. They rotate with common angular velocity. If EF and EI are final and initial total energies, then EF minus EI is. So we have two coaxial disks. Initially they are, you can say, rotating separately. So let us suppose this is one of the disk and this is another disk, and they are both coaxial. So let us call this as disk 1 and this as disk 2. Disk 1 is having moment of inertia of I1, disk 2 is having moment of inertia of I1 by 2 and angular velocity omega 1, and its angular velocity is omega 1 by 2. This is the common axis, and after some time they are brought together and something like this, and they are rotating this way, and it is given that EF and EI are final and initial total energies. Okay. So we say this is the initial condition, and this is the final condition, and in the final condition we assume that they are moving together now with the angular velocity of omega f. Okay. So for disk 1, moment of inertia is given as I1 and angular velocity is omega 1. Therefore its initial angular momentum let us call it as L1 initial, will be equal to I1 omega 1. For disk 2, moment of inertia is given as I1 by 2 and angular velocity is given as omega 1 by 2. Therefore we can say the initial angular momentum for disk 2 initial angular momentum for disk 2, let us call this as L2 initial, and this will be equal to I1 by 2 multiplied by omega 1 by 2. So we can write that our L2 initial will be equal to I1 omega 1 divided by 4. Therefore total initial angular momentum. can say total initial angular momentum, let us call this Li, is equal to L1 initial plus L2 initial. So we get Li is equal to I1 omega 1 plus I1 omega 1 divided by 4. This will be equal to 5I1 omega 1 divided by 4. So we get the initial angular momentum. Now we say that the final angular momentum, and we assume that both the disks now are in contact and they will be moving together with the angular velocity of omega f. You can say final angular momentum, and let us call this LF, which will be equal to I1 plus I1 by 2 and multiply by omega f, where omega f is the common angular velocity. Omega f is common angular velocity. Therefore, we can say LF will be equal to 3I1 omega f divided by 2. So this is our final angular momentum. Now, using conservation of angular momentum, using conservation of angular momentum, initial angular momentum, that is Li, is equal to Lf. Substituting the values, Li was our 5I1 omega 1 divided by 4 is equal to 3I1 omega f divided by 2. I1 cancels out and 2 goes by this 2. Therefore, we can say our final angular velocity is equal to 5 by 6 and times omega 1. So we got the relationship between the final angular velocity and the initial angular velocity, omega 1. Okay, sorry, not initial angular velocity, but omega 1 is the common factor between disk 1 and disk 2. Okay, so we got the relationship between the common factor of disk 1 as well as disk 2. They both have a different angular velocity. Now we are going to use the kinetic energy. So you can say initial kinetic energy and first is for disk 1 and let us call it as KE1 initial, which will be equal to half I1 omega 1 square, and next is for disk 2, let us call that KE2 initial, and this will be equal to 1 by 2 I1 by 2 and omega 1 by 2 का whole square. So So we get from here total kinetic energy, total initial kinetic energy, total initial kinetic energy, and it is said that it is given as EI. So EI is equal to KE1 initial plus KE2 initial. Therefore, EI is equal to 1/2 I1 omega 1 square plus I1 omega 1 square, and this will be equal to 16. So adding this will be giving us value of KE, no sorry, not KE but E initial. Okay. So we can take 16 as LCM, so this will be 8 plus 1 and I1 omega 1 square. Therefore E initial will be equal to 9/16 I1 omega 1 square. So we got the initial kinetic energy. Now final kinetic energy. Final kinetic energy, which is given as EF. This will be equal to 1/2 I1 plus I1/2 and omega F square. So we get EF is equal to, this will be LCM with 3I/4, and omega F we already know in terms of omega 1. This will be 5/6 omega 1 whole square. So this comes as equal to 3I/4 and multiply by, this will be 25 divided by 36 and omega 1 square. This goes by 12. So we get EF is equal to 25 divided by 48 and I1 omega 1 square. So we got EI as well as EF, and we are supposed to find out EF minus EI. Therefore, EF minus EI, that is final energy minus initial energy, will be equal to 25/48 I1 omega 1 square minus 9/16 I1 omega 1 square. We can take common as I1 omega 1 square. So we will left with this 25/48 minus 9/16 and I1 omega 1 square. 48 will be LCM. So this will be 25 minus, and we have this 3 and this will be 27. I1 omega 1 square. So the difference is equal to minus 2/48 I1 omega 1 square, and this goes by 24. Therefore we get EF minus EI is equal to minus 1/24 I1 omega 1 square. And if we see the option available to us, we can say that option number 8 is the correct option. You can say option A is So this completes the question. Thank you.